What if 8 billion people jumped at the same time? What would happen to the Earth? Would it shake? Would it wobble off its axis? Could it trigger an earthquake or alter the planet's rotation? At first glance, this might sound like a strange idea, but from a physics perspective, it's actually a fascinating question. Let's break it down scientifically. To analyze this scenario, we first need to define some baseline parameters. Currently, Earth's population is around 8 billion people. If we assume an average body mass of 62 kilograms per person, the total mass would be about 500 million tons. Let's say everyone is standing on a flat open area and jumps about 30 centimeters into the air. Just an average jump. The mechanical energy generated in this action can be estimated using the gravitational potential energy formula. M is the total mass. G is the gravitational acceleration, 9.8 meters per second. H is the jump height. Plugging in the numbers, we get roughly 1.5 trillion joules of energy. But what does that number mean? Is it enough to move the Earth? So here's the question. Would the energy from 8 billion people jumping be enough to make the Earth feel it? Let's compare. The Earth receives about 174 petawatts of solar energy continuously, about 150,000 times more than what this jump would generate. Even if all the energy was concentrated in one spot, it might cause a minor ground tremor, something like a 0.6 to 1.0 on the Richter scale. But in reality, people are spread out all over the planet. That means the forces from all directions would cancel each other out, and in total, the net impact would be close to zero. So from a physics standpoint, the Earth would barely notice. Now let's push the boundaries of realism and imagine that all humans are gathered in a single location. If 8 billion people with a total mass of about 500 million tons jumped at the same time in one place, the force would be concentrated. Upon landing, the area would receive a sudden jolt of energy that could generate a localized tremor, possibly around 3 to 4 on the Richter scale. This could cause surface cracks, shaking of weak structures, or even slight shifts in soil pressure. Interestingly, such a synchronized landing might generate a powerful air pressure wave, a shock wave that spreads across the surrounding area. As we've seen, even if all of humanity jumped in perfect synchronization, whether globally or in one location, the impact on the planet would be negligible. That's because the total human mass is incredibly small compared to the mass of the Earth, which is around 6 times 10 to the 24th kilograms. By contrast, humans together only weigh about 5 times 10 to the 11th kilograms, less than 1/billionth of the Earth's mass. Earth's enormous mass and high inertia make it naturally resistant to small external forces. In the end, no matter how well coordinated our jump might be, it's not enough to shake a planet. But thought experiments like this help us understand fundamental scientific concepts, energy, momentum, mass, and appreciate just how colossal our home planet really is.